3, 2, 1, let's go! Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we will be talking about the slice method on arrays and strings. No, it's not like taking a slice out of a pie where you just cut it up and take it on out. Nope, this actually makes a copy of certain sections of the array or of the string. Want to see it in action? Let's take a look. Now the slice method works exactly the same way on arrays as it does on strings. So I'm going to show you how slice works on arrays, and I'm going to go into great detail about how it works inside arrays. Then I'm going to very briefly show you how it does in strings. So let's go to the array first. Well, here's my array. It's just a simple 9-element array. And here is the slice method. I've got 7 different examples here because show you all different kind of combinations. Now, the slice method takes 2 arguments, what's called a start index and an ending index. The start index is the beginning of, or the very first index within the array that the slice is going to begin the copying method. Now remember, arrays are always indexed starting with the number 0. So if I start with index number 3 here, that's going to be the 4th element. In this case, 1, 2, 3, 4, cow. So I would expect this particular slice method to start with the cow. The second argument is the ending index. In this case, it'd be number 6. Now the very important thing to remember about the ending index is that the ending index will never include that index itself. So for instance, I have number 6 here. So that's 0, 1, 2, 3, 4, 5, 6. The 6th one's dolphin. But since the array slice will never, the slice will never include the ending index, I know for a fact that it's going to give me cow, coyote, and roadrunner, and that's all. And again, how many elements would you actually get? You can actually take a look at the number here and subtract the ending from the beginning, and you'll get 3 of them. So 1, 2, 3. So again, the start index is the starting place for the slice, and it will include the starting index, but the ending index will not include the actual ending index. It will include the one just before it. So what happens if the ending index isn't specified, as in this particular case that I highlighted here? Well, then it defaults to the length of the string, length of the array, excuse me. The length of the array is 9, and so it will not include index number 9. So I got index 3, 4, 5, 6, 7, and 8. So basically, if the ending index is not specified, it will take it to the very end of the array. And we've already covered that one. Here's an instance where the beginning index can be a negative number. Well, what does that mean? Well, that means the offset from the ending index is going to be the starting index. So the offset for the starting index here is 2, so that'd be -1, -2. So I would expect this output to start with well as my starting index. And since there's no ending index, it goes to the end of the string. Well, the ending index can also be negative. So what does that mean? Well, that means exactly the same thing. It is an offset from the ending. This again is going to start at index number 3, which we already know happens to be cow, and it's going to offset from -1 will be the index. Well, will be the final index. Well, my length is 9, so I subtract 1 from that. It gives me 8, so it's going to be 3, 4, 5, 6, and 7. So go from cow to well. It won't include lizard because remember the ending index never includes the actual number. What if both of them are negative? Well, it works the exact same thing. Offset from the ending, offset from the ending. So offset 3 from the ending, 1, 2, and 3. So we'll start with dolphin. Offset 1 from the beginning, lizard. It will end with lizard but not include lizard, so I should just get dolphin and well. What if the starting index is negative and the ending index is positive? Well, it'll return nothing because that can't be done. So don't even try to worry about it. And what if both of them are there? Well, not there. If both arguments are not there, the beginning index or the starting index is always 0, and the ending is always the end. So you get a copy of the entire array. So I've just got a bunch of little console.logs here to show you exactly what I mean. So let's pop over into Node, and let's run it and see what we get. A lot going on here. This first part, this little index legend that I have here, just kind of gives you the indexes, the numbers that we use here. Remember, indexes within arrays always start with 0, and this shows you the offset numbers if we happen to use negative. So let's just check all these out. Starting index of 3 should start with cow, and sure enough it does. Starting index of 3 is cow. Since there's no ending index here, it goes to the very end, and that checks out. 3 to 6 should start with cow and go to number 6, but not include number 6, so we end with Roadrunner. Sure enough, cow, coyote, Roadrunner. Negative 2 starts with the negative 2 offset from the ending, which will be whale, and gives me to the very end because there is no ending index. Sure enough, whale, lizard. 3, negative 1 starts with number 3 here, which is cow, and goes to the negative 1 index, which is lizard. But again, doesn't include the negative 1 index, so I should get cow to whale. And sure enough, cow to whale. Negative 3, negative 1, 3 offset from the end, which start with dolphin. Negative 1 offset from the end, which will end with lizard, but does not include lizard, so I should just get dolphin and whale. Sure enough, I get dolphin and whale. Negative 3, 2, it's impossible, can't be done, so nothing gets returned. And finally, absolutely nothing is specified, no starting index, no ending index. That assumes that the starting index is going to be 0, and the ending index will be the length, which will be the rest of the string, the rest of the array, excuse me. So that'll give me cat all the way through lizard. So yeah, everything checks out, cat through lizard. So this is how you use the slice inside of arrays. Now I'm going to show you how it works with the string, and it works exactly the same way, except now we're looking at characters instead of elements within the array. So let's now look at the slice method within a string. Like I said with the array, it works exactly the same way, except instead of dealing with the elements of an array, we're dealing with the actual characters of the string. So let's take a look and see what I have here inside my handy dandy IDE. Here is my string, and it's just the alphabet A through Z. So we already know that there's going to be 26 different character positions here. Here are all the slice methods, showing you basically the same slice methods as we did before. And I have now got the string index legend. This legend will give you, just like with the array here, will give you the different character positions at the very top, and at the very top for the positions, at the very bottom for the offsets, and then I'm just going to print them all out and show you how they all work. So the easiest thing to do is let's flip back over into Node and take a look and see what happens. So let's go to Node, and let's type in Node string. So here's my legend. Here are the different indexes for all of the different characters. And again, remember, everything starts at 0. Here are the different offsets for all those characters. So this starts with the 13th character and goes to the very end because there is no ending index. 13th character should be 11, 12, 13, should be the letter N, and goes to Z, and sure enough it does. 15 through 20, there's 15 through 20, but then remember, it doesn't include 20. So it goes to T. Yep, that's correct. Negative 5, we start at negative 5. Negative 5 is right here. Goes to the very end because there's no ending index. V through Z. Yep, works great. 10 through negative 5. So here's 10 to negative 5, but doesn't include negative 5. So we should be K through U. And it is. Negative 5 to negative 1. Negative 5 to negative 1. Doesn't include negative 1, so V through Y. Yep, there it is. Negative 5 to 2 does not work, because remember the ending index must be greater than the starting index. And of course, with nothing there, it gives you the entire string. And so just like arrays, again, this makes a copy of the array or a copy of the string. So we're not actually slicing anything out of it. The original string is still there. We've just made a straight copy of it. And that's very important when you're having to deal with objects, because I'm going to show you one really nasty little gotcha if you're not careful when you're dealing with objects within an array. And that's next. So earlier I said that slice will copy your array or your string. That's not 100% true. And let me tell you why. What it actually does is make a shallow copy. And that's very important when you're having to deal with arrays. Now, what do I mean by a shallow copy? Well, let's kind of go back and give you some JavaScript internals. Now, I'm going to be very generic here. But basically, variables are stored physically in memory as either what we call a primitive or a structural. Primitives are like strings, numbers, booleans, big ints, things like that. While structurals are something like functions or objects. And that's very important. When you assign a variable to a primitive number, let's say 1, 2, 3, for example, it will physically store 1, 2, 3 in a memory and set A equal to that 1, 2, 3. If you then say let B equal A, then what will happen is that since that's a primitive, a physical copy of that is made and put into another memory location. And so now A equals the 1, 2, 3, B equals 1, 2, 3, but they are completely two different 1, 2, 3s within physical memory. And that's how primitives work. So when you make a copy of a primitive, it just makes the copy and just goes on forever. And everybody is happy, everybody is content. Objects work a little different, or structurals work a little different. If you said let A equals an object, that object is then placed inside memory, but what gets saved with A is the address of that object within memory. It's called a reference. So A refers to the memory of that object, or the memory location of that object. So if I had an object located here in memory, A, instead of saying A is equal to this object, A is actually equal to the address of this object. So then when I say let B equals A, what gets copied is not the object. What gets copied is the reference. So A is referencing this object. B is also now referencing this object, which means if I change a property within B, let's say there was a property called name within the object. If I change name within B, it will also change within A because they are both referring to the exact same object. And there's one of the gotchas you're going to have when you're using the slice method with arrays. That if your array contains objects, what's going to get copied is the reference to that object, not the physical object itself. So that if you, in your new array, your new slice array, if you then change a number, it's going to change back into the original array. Let's see exactly how that works. So I'm in here, back to my code, and I've got an array here, and this array has just a very simple collection of objects, and each object has two properties, A and B. And I'm going to slice off 2 and 4 into new array. So what new array should end up being is a 2-element array, starting with the second element from old array, which is 5 and 6, and going to the next and last element, which is 7 and 8. So new array is going to be a 2-element array. Old array is going to be a 5-element array. I'm going to console log old array and new array here. But then what I'm going to do is that the zeroth or the first element of the new array, the A property of it, I'm going to change to the number 700. So that will mean that new array, the 0 element of the new array property A will be equal to 700. But remember, since it is copied as a reference and not a physical copy of the object, what will happen is that the second element, which was the old beginning element of the new array, that A should also change to 700. So what will happen is that although I've changed new array and thinking everything is grand and cool, old array is not going to change, you'll find that new array does. Let's see how that actually works inside Node. So let's go over to Node, type in Node object. So here's my old array. As you can see, no problem. Here's my new array, and as you can see, it copied 5 and 6 and 7 and 8. And then I've changed the A property of the 0 element of new array. So here's the new array. As you can see, the 0 element got changed to 700, but so did the second element inside the old array. Again, because I did not make a physical copy of the objects, I actually copied over the references to the objects. So if you're going to use the slice method, and this actually holds true for any of the array methods that happens to create new arrays. The filter method, for example, is a very good one. You have to be aware of what kind of data you are dealing with. And if you're dealing with just straight numbers or characters or anything like that, no big deal. It's going to work great. You'll make a physical copy of it. But if you are dealing with things like objects or functions, you will be making a shallow copy, and it will just copy the references of those objects and not make a physical copy. How can you make a physical copy? Well, look up on Google what's called deep copy. And deep copy will have some sort of library or something to allow you to be able to make deep copies of your arrays. And so that's what you'll have to do if you want to try to use the slice method onto an array that has objects. I just want to make sure you are aware it will make a shallow copy and not a deep copy. And that's how you can use the slice method on arrays and on strings. And that's all there is for the slice method on arrays and strings. I hope you enjoyed our video. Hope it didn't bore you to death. Please check out our other videos at www.boringjavascript.com. Subscribe to our YouTube channel or check us out at blog.thevirtuoid.com. Thanks again for watching, and we'll see you later.